All right, so 2.1 basics of functions. All right, determine whether each is an equation that defines y as a function of x. So that's the first. Okay, somebody said, I don't think we had the open discussion. All right, let's pause right here. So, did we not have the review day? I know one person said, they don't think we had it. I thought we did it Wednesday. I may be mistaking it with another class. I know she said she think. So, anybody else? Nobody?
No, Wednesday, I thought we did the 1.7 on Wednesday.
Oh, okay. That's 2 on that. All right, that's cool. So, if that is the case, then let me pause right here. Did anybody have any questions on anything? Anybody have any questions on anybody try anything, get stuck? See somebody come up here. Do something loud. So we were supposed to be doing a review today. I see somebody in the chat. Give me a second. All right, so let's see what's going on 1.4. All right, so somebody said they got stuck on 1.4. So can you be a little specific? Give me a problem that you want to see or something like that. Let me see, what was 1.4? So complex numbers. So was it something in particular about complex numbers that got you stuck? So remember, if we were talking about review day.
Yeah, hold on. I'm trying to go to my math lab and find a problem.
Okay, not a problem. All right, while she's looking for that, anybody else? Anything else? So we're talking about all of chapter 1 through 1.7. We had complex numbers in there. We had quadratic equations, linear equations, linear inequalities, absolute value equations, absolute value inequalities. All right. Anybody can think of any type of problems they want to see, or is everybody good? I know, like I said, we're waiting on her. That's fine. But anybody else can think of any type of problems? Yeah.
Can we go over what we worked on Wednesday?
All right. What you mean by that? Did see? I see a 5 plus 3i minus. Hold on a second. We got. Let me see. Plus. So now when you say we worked on Wednesday, you know, we did absolute value, inequalities, and linear inequality. I think it was linear. Yep. So,
Actually, I think I probably meant that Monday. I was talking about when we were finding the least common denominator to solve when there were fractions on both sides of the equal sign.
okay. All right. Hold on. I think I can find you a problem like that. All right. So let's do this one. This is one of the ones that was presented. So you're talking about just subtracting or simplifying this expression.
Yes.
So what you want to do is distribute this negative first. Make sure that negative is applied to each term that in the following parentheses. So it's going to be 5 plus 3i minus 7 plus 3i. So both of those signs change back here. And then you just combine your like terms. 5 and negative 7 is negative 2. And then you have a positive 3i. Positive 3i will give you a positive 6i. And that will be what you would do for that. So any questions on that one? Can't find my stuff. There you go. Now, for the one who asked about a problem with fractions, are you talking about something like this? Are you talking about something like that?
Yes, because you put two fractions on one side.
Okay, let's do this then. All right, so we have 3x over 5 minus x minus 3 over 2 equal to x plus 2 over 3. So the first thing you want to do is find your LCD. And least common denominator, or least common denominator of 5, 2, and 3 would be 30. Smallest number that that 5, 2, and 3 can divide into evenly. Smallest number that both, like you want to say both because normally dealing with 2, but the smallest number that 5, 2, and 3 can divide into evenly. All right. Then you're going to multiply each numerator by the LCD. Multiply each numerator by the LCD. 5 divides into 30 and leaves you with 6. 2 divides into 30 leaves you with 15. 3 divides into 30 leaves you with 10. So before we go any further, make sure we're okay. Found the LCD of each one of your denominators. Multiply the LCD to each numerator. Simplified by dividing the denominator into the LCD And that leaves us with what we have right now, 6 times 3x, 15 times x minus 3, and then 10 times x plus 2. We can simplify further now. Don't forget to distribute negative 15, not just 15. 18x minus 15x plus 45 equal to 10x plus 20. All right. Combine the like terms on his left side. I got 18x minus 15x. That'd be 3x. All right, now we need to get all of our terms with x on one side, all of our terms without x to the other. So I subtracted 10x from both sides, so they'll cancel. Subtracted 45 from both sides, so they'll cancel. So there's negative 7x equal to negative 25. All right, divide by negative 7. X is equal to 25 over 7. All right, questions. All right, anyone else have a problem, a type of problem they want to see done? All right, anything? So everybody is good.
Can you do one on solving linear inequalities?
Let's see. One other section. I'll go ahead and use that. So here we have 3 times the quantity of x minus 8 minus 2 times the quantity of 10 minus x. It's greater than or equal to 5 times the quantity of x minus 1. And of course, we're going to solve for x. First thing we'll do is go ahead and distribute. Here we'll distribute 3. Here distributing negative 2. Here we'll distribute 5. That's 3x minus 24 minus 20 plus 2x. And then 5x minus 5. I will simplify everything on the left side first. So combining like terms, 3x and 2x is 5x. Negative 24, negative 20 is negative 44. This one ended up canceling out. You sure got my stuff right. Yeah, there's 2x, 3x, 5x. Okay, so this one though ends up, our variables end up canceling out when I minus 5x from both sides. So negative 44 is greater than or equal to negative 5. That's a false statement. So because of that, your answer is no solution. So whenever you solve your, whether it be your equations or your inequalities, your variables cancel and you end up having a false statement. Your answer is no solution. All right, questions on that one before we look at next one. I meant to minimize the screen. All right, any questions?
Can we do one more of this one where we do get a solution?
Well, I was gonna do that next one right here.
Oh, my bad.
Yeah, no problem. So here we have 4x minus 3 is greater than 3, but less than 19. So here we want to solve for the x in the middle. So the same thought process that we would take on here, just that our stuff is in the middle. So add 3 to all 3 parts. B6 is 22. Divide by 4. So that reduces to, oh, not 2/3. 3 over 2, x, 11 over 2. Now if you want the graph, and you have bracket, remember the or equal to sign tells you use bracket. If you don't have that, then you should be using parentheses. And in this case, we'll shade in between the 11 over 2 and the 3 over 2. Then our interval notation, we're going from 3 over 2 to 11 over 2, bracket, and parentheses. All right, any questions? All right, any type of problem, any other type of problems? Are we good to go? Don't forget, there is a test review in my math lab set up like a homework so that you can review that and try those problems out. It should streamline your studies for your test. So you're not going into your test blindly. So always make sure you check that out. Remember, if you do it, you get 85 or better, then you get +5 on your test, but you don't have to do it. It's not mandatory. So even if you just look at it and don't make an attempt, you should at least take a look at it so that you'll know what to study for as far as the test is concerned. Test is due, we talked about, should be this Sunday. Nope, Monday. The day after Valentine's Day. Said I will give y'all Valentine's Day. And so the 15th, everything chapter 1 stuff should be due 15th.
Can we do a quadratic equation where we have to find the u and then solve?
All right. Let's see. But there's not one type like that necessarily that you want to see. Just let's see. Yes, somebody asked for test 1. Do you need to send a copy of your work? Yes, don't. So great question. Don't forget for each test that you submit, whenever you submit a test, whether it be test 2, test 3, or whatever, you're always going to send me your scratch work. So yeah, great reminder in that front. All right, so here we have x to the 2/3 minus x to the 1/3 minus 6 equal to 0. So we have an equation. When we look at it, x to the 1/3 squared. This is x to the 1/3 minus 6 equal to 0. So whenever we have this type of scenario, we have an equation that's in quadratic form. In other words, you have this term and then in front this term squared. All right. So if that's the case, we can let u be equal to x to the 1/3 in order to simplify the equation. And that'll give us u squared. I'm gonna go back to black. U squared minus u minus 6 equal to 0. So before we go any further, questions on what we did there. So you recognize that you had an equation in quadratic form. It's only in quadratic form if you have the term that's in the middle that's being squared in that front as your leading coefficient or your leading term.
Why did you have like square on it anymore? Second one.
You talking about right here?
No, no, the other one.
You talking about right here?
Yeah.
You said, why don't I have the square?
Oh no, sorry. U that has no square. That doesn't have like a cube or something.
Oh, the cube. Well, it's still there. We're letting the u represent the x to the 1/3, and we're gonna come back to that.
Oh.
Yeah. So we just letting u be equal to x to the 1/3 for right now, just to help us with the simplification process. And to solve, after we solve for u, we're going to bring this back into the equation. All right. And so, like I said, you only do this just to help you with solving. But then when we get down and we solve for u, when we have u equal to, let's say if it's u equal to 5, then we bring this back in and solve for x. All right. So let's go ahead and do that. At least I think, did that answer your question? Before I go.
Yes.
Okay, just want to make sure I actually answered your question. All right, so I would solve this by factoring. Once again, don't forget, if you're not comfortable with factoring, you can always use your quadratic formula. So this would be not x, u minus 3, u plus 2.
Another question: how do you
Mhm.
know which one is negative number and which one is a positive number?
That goes back to your factoring basics. So basically, you will look at this and say, because that sign, your second sign is negative, you know your signs and your parentheses are going to be different. Right? And then this one lets us know the greater of the two would take on that sign. So that's why the 3 is negative. So if you were to fold this back out, that'll be u squared. That'll be 2u. That'll be negative 3u. That'll be negative 6. And now when I add these together, I get my negative 1u back. That's in the middle. All right. Hopefully that was good. And here, add 3 to both sides. That's u equal to 3. Subtract 2 from both sides. That's u equal to negative 2. So before we bring our u back to x's, questions on how we got to that part. All right. So like I mentioned to your classmate, now we bring u being equal to x to the 1/3 back into the equation because we need to solve for x, not solve for u. I should have stayed black. All right, so now we have x to the 1/3 equal to 3 and x to the 1/3 equal to negative 2. Now to solve for x to the 1, now to solve for x, I'm going to cube both sides. All right, cube and the 1/3 will cancel, leave me with just x. 3 to the 3rd power is 27. Once again, the 1/3 or the cube root and the cube cancel, leaving you with just x. Negative 2 cubed is negative 8. Those would be your 2 answers.
Can you scroll up a little bit more?
Not sure how far you want me to go. So a little bit.
Yeah, you can start right there.
All right. Any other questions? Anything else? All right. Any other type of problems? Everybody good?
I don't know if you think it's like cheating or not, but I had did the homework, and one of the questions really got me, and I wanted to know if we could do that one.
Oh, what you got?
Give me a second, let me write it down.
Okay.
Okay, so I got it.
All
It's
right.
big parentheses, x minus 20 over x, close the parentheses, squared, minus 7 parentheses, x minus 20 over x, parentheses,
Mm-hmm.
minus 8 equals 0.
All right. My pen acting funky. Trying to figure out what's going on with my pen. Hopefully that'll help it. Yeah, there we go. All right, so is that written right? You got x minus 20 over x squared minus 7 times x minus 20 over x. And you said minus 8 equal to 0.
Yes.
Okay. So now really we can do this problem the same way we just, I believe it was the last one. Yep. Notice that we have x minus 20 over x, and then we have x minus 20 over x squared. We can actually let u be equal to, let's run it together again. Maybe I need a new battery. But let u be equal to x minus 20 over x. If we do that, then I'm left with is u squared minus 7u minus 8 equal to 0. So it's still an equation in quadratic form. All right. So I will go ahead and factor this. Hold on one second. All right, and set each piece. Hold on, one should be plus. That's negative, so it should be u minus 8, u plus 1. Yeah. And set each piece equal to 0. All right, solve for 8. That's going to be u equal to 8. Here, it'll be u equal to -1. Trying to see if a new battery will help that. So before we go any further, questions on what we've done?
So you just took the value of u and canceled everything in parentheses?
Now, I didn't cancel it necessarily. I'm going to substitute it back in after I've solved. Let's see, does this make a difference?
So now that you figure out what u is,
Mm-hmm.
do you have to make that equal to what you substituted for u and then solve for the x inside?
Yep, you got
Okay.
it. I'm just
Just
saying.
making sure.
Mm-hmm. Oh yeah, you're fine. Just trying to see what's going on with this pen. Starting, you see it's dragging or something. And I got a light going on. Anyway, I figured out. So like she said, remember that u is equal to x, was it x plus 20? X minus 20 over x. So now we plug that in.
No, it was 20 over x.
Hmm?
I thought it was 20 over x.
Oh, okay. So it was 20. It wasn't x minus 20 over x.
No, it's just, I thought we had just made it, we made it x minus 20 over x.
Yeah. So it was just 20 over x. See, I got the original equation. So you telling me it was just 20 over x?
Oh, no, yeah, that was inside the parentheses, x minus 20 over x. I just didn't realize we had made that the
Yeah.
u. I thought we just had the u as 20 over x. So
Oh no,
that's
the u is the whole. Yep, the u has to be the whole thing. Whatever's being squared. See, right here we have x minus 20 over x, and then what's being squared is x minus 20 over x. So both of those have to be the same. And so, yep. All right. So x minus 20 over x is equal to 8. Oh, that's not 8. X minus 20 over x is equal to -1. And he said this wasn't on the test review, was it? Or the test, was it?
no, this was one of the homework
One of the
questions.
homework. Okay. I was about to say I didn't think I put one like this on the test. All right. So we need to get x out of the denominator, so we multiply both sides by x. All right. So this x will cancel. And let me do it like this. To make it more clear. All right, let me do it like this. So I'm gonna multiply both sides by x. All right, so now the x's will cancel. X's will cancel here. X minus 20 is equal to 8x. X minus 20 is equal to negative x. So make sure we're okay with what I've done. I need to get the x out of the denominator, so I need to multiply both sides by x. The x cancels on the left. Get it out of that denominator, but you multiply it times the number that's on the right. So on the left side, we have x minus 20 equal to 8x. On the right side, x minus 20 equal to negative x. All right, now we want to solve for x. Subtract x from both sides. Negative 20 is equal to 7x. Negative 20 is equal to negative 2x. And we can finish it off by dividing both sides by 7. Here we divide both sides by -2. 7's cancel. -2 cancel. Here my solution is -20/7. Here my solution would be +10. All right, questions? Any questions?
The answer that it put for that problem, it said that the solution sets were -5, -2, 4, and 10.
All right, let's make sure I didn't miss anything. And when you look at the equation that I have right here, I didn't miss anything. You got x minus 20 over x squared, x minus 20 over x here. When you look at the original problem. Let's see. What number was this? As well, so I can go back and take a look at it.
It was question 8 on the 1.6.
8 on 1.6. And then, like I said, though, so you said that this is the correct way that it's written as far as what you saw?
Yes.
All right, let me see what's going on here. Oh, man, I'm in the wrong class. Okay. Let's hold on a second, trying to get there. And said 1.6, number 8.
Yes.
All right. I see nothing. So let me go back and look at my notes. I mean, look at my setup. X minus, so that X cancels. Oh man, stuff closed out on me. Okay, so let's try to solve it this way. Let me go back. Oh, that's square. I can't square it initially. So I multiply X right here. Let me try one more thing before I go that route. Oh, I see what it is. Okay, the question was written different. Let's go back. So it was like this, which makes all the difference in the world. So that bar wasn't extended over or under the x and the x minus 20. It was just under the 20. So that changes this x minus, yep. So that doesn't change any of this. But when we get here and when we go to solve, and when we solve this, it's actually a little different in our cancellation. So, oh, this will be black. So now when I multiply each term by x, that's now going to be x squared. Because see, the x's cancel out right here, but that's x times x right here, which gives us x squared. And then the same thing happens over here. So you multiply x to each term. The x's cancel out in that second term, but in that first term, they don't cancel out. It's just x times x. So that'd be x squared minus 20 equal to negative x, and then the other one is x squared minus 20 equal to 8x. All right, so let me erase this stuff. All right, but before I go ahead and do that, but you see where the difference was and how it happened, and make sure we're okay, because I know you had the question on it, so I want to make sure you're okay with what happened.
Yeah,
So,
I can see it.
all right. So now we have a quadratic equation. This is why you got 4 answers, because you have a quadratic equation in both scenarios. You have a quadratic equation over here and over here. We're still going to subtract or set one side equal to 0. Here we'll add x. X squared minus 8x minus 20 is equal to 0. X squared plus x minus 20 is equal to 0. Here, let's see, 5, we got 20. Yeah, here we're going to have to use the quadratic formula. Yeah, I'll just solve by factoring. And then over here, a is equal to 1, b is equal to negative 8, c is equal to negative 20. So you're talking about x equal to negative b plus or minus b squared minus 4ac all over 2a. So that's negative 8. Let's see if I can squeeze all this in here. Probably not. Let me slide it over. So it's negative 8 plus or minus negative 8 squared minus 4 times 1 times negative 20 all over 2 times 1. So 8 plus or minus 64 plus 80 all over 2. And make sure it's 80, 64. Oh, I could have factored this. Okay. 144 over 2. Over 2. Just like this. My stuff, this pen is acting crazy. Okay. So 8 plus 12 over 2. 8 minus 12 over 2. 20 over 2 is 10. Yeah, I forgot about 2 and 10. And then here, negative 4 over 2, which is negative 2. So we got negative 5, 4, 2, and negative 10. Hopefully those were your 4 answers. If not, I had to double back and see what else may have been written wrong. Make sure I got it right. So that was just an example of also, remember I always say that you can use the quadratic formula to solve if you're not comfortable with factoring. So notice how one side of factor, the other side I use the quadratic formula. Either way, you'll get your solutions. All right, questions, concerns, comments, anything? All right, so anybody have anything else before we close out today?
Could you give us an example on how to calculate percentages again?
You got to be a little more specific on that when you say how to calculate percentages. What do you mean? You say how to calculate. Are you just talking about 10% of 30, or I'm not sure what you mean by calculate percentages.
Okay, so say the question's like the price of something is $228 after, hold on.
Mm-hmm.
Sorry. Okay, something is $228 and it's that price because of a 70% reduction. So how much was the original price?
Oh, okay. So the price ladder is $228 after a 70% reduction. We want the original price. So we'll let we will come from the idea that we have an original price minus the reduction. and that's equal to the sale price. All right, we can call the original price X, call the sale price 228 because we know that's how much it costs now after the reduction. So now we have this 70% reduction as a decimal. That's going to be 0.7. And whenever you look at this relationship, the sale price never existed until after the reduction. So where a lot of people make a mistake is they want to take 70% of the 228. Well, that's impossible because that couldn't occur until after the reduction. The 70% is of the original price. So you're doing 70% of the original price, but your original price is X, and of means multiplication in mathematics. So you're looking at, this means 70% of original price. So when you do 0.7x, x is our original price, of means multiplication, and 70% is 0.7 in decimal, so it's 0.7x. And so that's how we would set up our equation. And then to solve, combine your like terms. Don't forget there's a 1 that's sitting in front of this x. So that's 1 minus 0.7, which would be 0.3x. All right, so that's 1.0 minus 0.7, give you 0.3. And now we can divide both sides by that 0.3. And that'd be 760. All right. All right, so was that okay? That makes sense?
Yeah, I understand.
Okay, cool, cool. All right, anything else before we close out? All right. Well, so next class we'll be looking to start in start in chapter 2. If you have any other questions that are generated, feel free to email me. I know some people emailed me on Sunday. Didn't answer any emails Sunday, so I'll be looking to answer some things today. So if you did answer me some emails either Sunday or very late Saturday, give me a chance to get to them today and everything like that. Outside that, you guys have a good one. Have a great day, and I will see you on Wednesday.
Bye. Have a good day.
Thanks. You do
Bye.
the same. Take care.